working on scientific notation, some of this may be review for you, but some of it will be new. Let's take a look. Write the number in scientific notation. It's a very large number, so to write it in scientific notation, we take the invisible decimal that is right here and move it until you find a number between 1 and 10. So, as you move it over there, you will go 1, 2, 3, 4, 5, 6, 7 spaces until you get a number between 1 and 9. Notice that this number right here, 4.259, is a number between 1 and 10. Sorry. Make sure it's a number between 1 and 10. If I had stopped here, it would have been 42.59, way too big. Anyway, so I moved it over 7 spaces, so I put times 10 to the 7th power. Same thing happens here, but what happens when this is a very small number to start with? We still go ahead and move the decimal until we get a number between 1 and 10. So go 1, 2, 3, 4, 5, and we moved it over 5 spaces. The number 5.74 is a number between 1 and 10, so that is correct. And we have 10 to the negative 5 power because this was a decimal and it was a very small number, so we should have a negative exponent. All right, let's take a look at some more work. Now, writing these into standard form. Here is scientific notation. To change it to scientific form, I just go ahead and I move the decimal. It says 10 to the 6th power, so this number should have been a lot bigger. So I move it 1, 2, 3, 4, 5, 6. And those 2 places have to be held by a 0. So that's why you will see 2,007,500 is your answer. You have to place 2 zeros to hold the place value and move it 6 places. All right, now this number is a very small number, and how do I know it was a very small number to start with? It was to the negative 4th power. That negative 4th power tells me I need to move my decimal over to the left 4 spaces. So I take it and move it 1, 2, 3, 4. Put the decimal, hold your place value by placing the zeros. Okay, so 0.000165 would have been the number, and that's what you see over here. So positive exponents, once again, make the number originally very large. Negative exponents means the number was very small, so you must go the opposite direction. All right, some for you to practice on. Please write down this number, and then write it in scientific notation. And then for number 2, take this number here that's in scientific notation and change it into standard form. Pause your video and give it a try. All right, so for the first one, you should have been able to get 5.39 times 10 to the 5th. And for the second one, it was 4.5, I'm sorry, the final answer, because it's supposed to be in standard form, is 0.00045, and it was very small because it had that negative exponent. All right, let's try another type of question. Example 3. Order these 3 numbers. Well, this is a huge number over here, 103,400,000. Compare it to 7.8 times 10 to the 8th power and 80,760,000. So you're supposed to be able to order them from least to greatest. So first of all, convert them all to scientific notation. So this number in scientific notation, this is a very large number, so we will have an exponent that is positive. And if we actually count, let me grab a pen real quick, and we keep moving the decimal that's invisible but over here. 1, 2, 3, 4, 5, 6, 7, 8. So 1.034 is a number between 1 and 10. I double check it, and yes it is. And so I moved it 8 spaces, so I say times 10 to the 8th. This number here, I'm going to be using a positive exponent because it's very large. 1, 2, 3, 4, 5, 6, 7. I move it 7 places. So it's 8.076 times 10 to the 7th power. All right, so now we have those 2 in scientific notation, and the 7.8 times 10 to the 8th was already in scientific notation. Now that they're all in scientific notation, we can compare. Let's go back here. We have 10 to the 8th, 10 to the 7th, and this answer up here, oops, that doesn't look so good. Let me grab an eraser. And let's go ahead and underline, we have this number here compared to this number here compared to this number here. These are our three numbers to actually compare. And anything, see how this is 10 to the 8th and 10 to the 8th? These two numbers have to be larger than this because this is times 10 to the 7th. So since this is times 10 to the 7th, this is a smallest number. So we're going to go ahead and write that as our smallest number since we're going from least to greatest. 8.076 times 10 to the 7th is our smallest number. Now, comparing these two numbers, we have 7.8 times 10 to the 8th and 1.034. Since they both have the exact same exponent, we look at the beginning numbers, 7.8 compared to 1.034. 1.034 is obviously smaller. So we write 1.034 times 10 to the 8th is the next size up compared to this one, 7.8, that's a point, times 10 to the 8th. That is the largest one in this group. So once again, make sure you compare the base with the exponent 10 to the 8th, 10 to the 7th, and 10 to the 8th first. This one automatically is smallest because it's 10 to the 7th. Place it there. And then compare front-end numbers if they have the exact same exponent. All right, let's give the next one a try. That's just more information. Now, obviously, they put them back into standard form for their final answer. All right, let's go to the next question. We have to order these from least to greatest. Make sure that you change them all to scientific notation, and then write them in order. Pause your video and give it a try. All right. You should have been able to come up with this order here. 2.75 times 10 to the 5th power, I'm sorry, 10 times 10 to the 4th power would have made this the smallest one. And then we have 3.401 times 10 to the 4th, and so on. Should have them in this order. All right, one last thing to try out. Evaluate the expression, write your answer in scientific notation. These are actually pretty easy. You're going to use the commutative property and take the 8.5 and the 1.7 and place them together. Take the 10 to the 2nd and 10 to the 6th and group them together. So we've used commutative and associative property. And now all we have to do is take 8.5 times 1.7, and you get 14.45. And then, of course, these have the same base. Add your exponents, 10 to the 8th. Now, this number is not in scientific notation because that says 14.45. We need a number between 1 and 10. So move that decimal one place value. When you do that, it changes this exponent to 10 to the 9th power because it was a little bit bigger. Originally, we have to make this add 1. Now, technically, this is how you're doing it. You changed it, you have 1.445 times 10 to the 1st power, just changing this to scientific notation, times 10 to the 8th. These two get grouped together, and so now you have 10 to the 9th, and you're all set. All right. These are also done the same way. You have to the 2nd power. So you have 1.5 to the 2nd power and 10 to the negative 3 to the 2nd power. So 1.5 to the 2nd power is 2.25, and 2 times the negative 3 gets you 10 to the negative 6. So there's your final answer there. That is in scientific notation because that number is between 1 and 10. How about division? We can do the same thing. We can go ahead and do 1.2 divide by 1.6, and you get 0.75. 4 minus a negative 3 for your exponent, you get a 7. Now this number is not quite in scientific notation. The decimal needs to move one place value over. So 7.5 times 10 to the negative 1 represents this. Keep bringing down your 10 to the 7th. Now you have 7.5. These two come together, and so we have negative 1 plus 7. So negative 1 plus 7 makes that a 6. So you have 7.5 times 10 to the 6th power. You may need to pause your video and rewind this and watch it a couple times. Pause your video and try these 3 questions. All right, welcome back. For this question here, your final answer should be 1.69 times 10 to the negative 10th. I should see all your work that supports that answer. On this one, we should get 3 times 10 to the 7th. And on the final one, 4.62 times 10 to the 9th. All right, make sure you have shown all your work for these questions. There's more work than just writing down these numbers. That's it for tonight. Have a great evening.